we are talking GridRunner. Now, I was going to try and make GridRunner into a cassette 50 game, but I've run out of space and I ain't even got to the snakes yet. I haven't even got to the snakes, so there's no way on this planet am I going to be able to make this into a cassette 50 game. So what I'm doing is I'm going to carry on coding it, but it's the start of doing it for all the platforms. So I have got this. So it's a Commodore book. I think it's just for the pet. Yeah, it is just for the pet. And I've got the master himself. So I've got programming the pet. I've also got programming the VIC and programming the 64. This is the start of trying to make the pet version, but I'm trying to make it for the C64 at the moment. So if I run it, I think I gave you a quick look at it on the last stream because I had a problem with it, but I've managed to go over. There's no sound in it, so, but there we go. Ship moves. I've got all the pods going on there. I've got the vertical and horizontal ship going, and I've got the bombs going. So now it's just getting the snakes in there and the death, because it doesn't die. I don't die. I don't die. And what I'm going to try and do is eventually, once we've got it all working, is try and then put some start using assembler directives where we can test the state of a variable and include that code and exclude other code. So we have one source code that can be assembled into the PET, the VIC, 664, Commodore 128, hopefully, C16, hopefully, +4. And if I can get a book on it, the Atari 400 or 800, it's one of those two, because I've got the Atari development environment set up to see if we can port the code over to there and see if it'll work. So this is the start of now taking that reverse engineered. We've recoded it. We'd finished it before. I have now rewritten it so far up to the pods using just ASCII characters. There's no custom characters in it. It's just using PETSCII character set, because I was hoping I would fit it in the cassette 50 memory requirements. But like I say, I haven't got the snake on it yet. But you never know, it might turn out to be a cassette 50, because I could take the lasers out and just leave and just let the snakes come down and see how much, but we'll get to that. So that's the plan for today, is to try and finish this off and try and recode it in such a way that we can just by changing variables be able to assemble it for a different machine. That's why I've got the PET book out, because this has got different, it's got different memory locations. I think BASIC starts in a different place as well. So like the screen starts at 8,000 if my memory serves me right. I'd have to look at my Frogger game, find out where I started it. But even here, even Mr. West, he was assembling code in 02A7. Like here, what's that? There's always sort. Oh, right, okay. A sort routine. And he just put that in 0287. So it looks like that memory's still available to us for the PET. But I've used other things as well. So I've got some utilities in here. So we've got, where's the screen location? So the row location. So you put the row in and you put the 0 page offset where you want to store the row location in 0 page. I've also got the print at string where it prints text at a location. I have a 2-stage 256 delay. So basically this does a 256 loop and then a 256 loop and then a counter on top of it. So it's doing a double 256 loop and then we are telling it how many times to iterate through that. We've got a single 256 loop, so it's a 256 loop and then I loop through it as how many times I want. So it's a quarter of the speed of the two-stage 256. Got the joystick capture, and then I've got a routine to grab a character at a location, to put a character at a location, and we put in the row and column where we want to look, the row and column where we want to look. For this put, we put the character in as well. And then I've got another one for putting colour at a location. But then I've created 2 routines that you can put a character at the same location as where you put the colour. And what I mean by the same location, it looks up the same location on the screen as where you put the colour attribute. And I've also got a colour one, put colour at same location. So if you've placed a character on the screen, this routine will place a colour at the corresponding colour cell in the colour ramp to try and make it a bit smaller, because Mr. Jeff was constantly loading the value, storing it in the screen location and doing the lookup and then comparing it, and it's just unnecessary. So these are the utilities that I'm running. So I've done the same philosophy as before. I've got rid of basic to give us some space, and we have got the game setup, and then we've got the game looper, and we're working within the raster. In fact, I don't know how much time I'm taking. Let's see. I've not actually done this to see how much time I'm taking. Right, here we go. Let's see how much time I'm taking playing this game so far. Wow, it's not a lot. The laser takes more time than anything else. Oh, how much time is that laser taking? Wow. Anyway, so as you can see, I've got most of it using Pesky graphics running. Fine, there's no sound there. But the pet, I don't think the pet has sounds, does it? I know it had a bleeping speaker, but can you access it? Can you access the speaker? Ooh, sound and graphics. 9.7. Oh, what page number was that? 282. 282. Here we go. Oh, that's doing the big graphics. Ah, sound. Where are we? Oh. Introducing computer synthesized music has been achieved considerable success, notably with the organ-like sounds and special effects. Okay. Where does it say? But how do you do it? Do you have to plug something into the back of the pet? I thought you could get the pet to make bleeping noises. Programming the speaker is fairly easy matter. The usual method is to use the VIA shift register at E848. The shift register moves one byte to the right at a regular time interval. Determine the clock. Okay. But it doesn't say. Oh, Mr. Zimmerman's music generator. So we'll have to try and see if we can replicate the bleeping noises in the speaker, because when the pet boots up, you get that noise, and I'm sure you should be able to program it. Have to look into it, but that's the plan. So once we've finished doing all this, is then to take this and then use assembler directives. So we're gonna have.
Hello, John here.
Ooh.
Thank you for following. Hope you enjoy the stream.
Who's that? Oh, thank you for following. Crete ID. And using variables, we should be able to exclude code and include other code specific to that machine. Now I'm hoping we're just going to be messing around with labels and numbers to put it going in different places. I'm hoping all the code's going to be the same, except for screen location, doing a clear screen, which I don't think I do a clear screen, and any other custom things. I mean, we're not even doing any characters yet, so hopefully we should be able to do it. So like I've done bomb control, which is where the pod decays into a bomb, and as you can see, I've got the characters for decaying. So the next thing I was going to start was the snakes. Snake control, that was the next one. So basically we're going to add the code in for the snake control. Now this is where it got really confusing with Mr. Minter, because he was doing lots of hokey pokey, and I want to try and avoid most of that. So let's get another file in place. Let's put the customary start stuff at the top. Right. So the way this works is every cycle of the game loop, you run the appropriate code, and in that code you've got a timer delay, and that timer delay determines whether you're going to run the code or not. So I think I have got timer. Here we go, snake timer. Now I'm not too sure. Yeah, that's the in fact, we'll rename that. Right, we'll rename that. So, snake control. So he decrements the snake master. So basically, this is the delay that we process the snake routine. So branch if equal to process snake. And then if it doesn't, we come out. Now, reset. Do I have a reset? Have I got a reset timer? Timer reset, snake. Have I got snakes? Here we go. Snake character, snake colour. Got no timer resets. Okay. No, not that. Snake, here we go. We'll put that in and store it in timer. So we're resetting the snake master timer. Now, when we're running through it, we're going to be we're going to need to insert the snake, and this so your master timer is the number of cycles we do before we process the snake. So that's the master timer, that's what we've done. Then we've got an insertion of the snake, so there's a massive delay before we insert the snake into the plane area, and then we've got another delay on the speed of the animation. If we're going to use animation, have I got characters for animation? Oh yeah, so I've got 2 characters for the animation, right? So what we're going to do is have I got the delays in? Yeah, so I've got number of snakes and this how long they're going to be. That's the delay for the fire. Right, okay. So we are using this to govern the way the levels operate. And so the insert snake is going to look after all the snake insertions. God, it's warm in here. Right, where are you? Let's see how he's done it before. Right. So we need another timer. In fact, we'll put it there. Because we need to record we need to delay the insertion of the snakes, because you don't want the snake to go in straight away and then the second one to follow straight after, and the third. So you need to have a way of delaying the way the snake gets inserted. So we need another timer. So we need another variable, and I don't think I've got one. So let's start another area called snake, and we need number of chars. That'll do. That's number of snake characters. And have I got... Yeah, level number of... Oh, no, I've got it there. Number of snake jars. Right, don't need that. So level number of snake jars and snake length. Okay, and number of snakes. Oh, even better. Right, so we are looking at the snake number of snakes for the level and number of snake characters. Level number of snake characters, that's the one I want. Right. So basically we're testing, are we in the middle of inserting a snake? So if it's not 0, then we're still inserting a snake. So we go to insert snake. Now, if we are in the if we've got no more snakes to insert, then we decrement the snake, the timer. So branch if not equal, insert snake. This is where it's why I get confused with these timers, because I don't want to copy his code, because his code's got a load of inefficiencies. So I'm trying to take what we did and what he did, and trying to code it properly. So load the number of snakes. If it's not equal to 0, insert the snake. If it is equal to 0, then decrement the snake counter. Now, that must be that one. If that's equal, go to branch if equal to it. Oh right, so this is, hang on, that's the master one, isn't it? No, it's not the master counter. Right, so we go into the insertion routine. We are checking currently of the snake we're inserting right now, how many characters are left. And if it's not equal to 0, that means there's characters left. It goes straight into the insert snake routine. Then we decrease the timer. So we are 0, so there's no more snakes left. So we're decrementing now a timer to insert the next snake. And that's why when it comes to 0, we go to any more snakes to insert. So this is where now we're going to check to see how many snakes we need to insert in the level, and if we do, we carry on. So we're going to load level number of snakes, that's it. And then if it's not equal to 0, then we need to define new snake head. And if it is 0, that means we've added the snakes to the game. We don't need to add any more. We just rotate straight back out and carry on with the game loop. Now, let's see how Mr. Minter added the snakes. Right, so I need the control array, the row and column array. Right, so I need to set up the arrays, and where are we going to put that? Where did I put the bullet array? Where's the bullet array? Hang on. Must be in game memory. Aha. Right, so I put it in there. Okay. So, how many bytes are we going to allow for the snake? I'll tell you what. How big have we got them? Right, snake length 19, and we got 7 of them. Wow. So 19 times times 7, that's the biggest one, I think. So that's AF. Wow. 18.7, 18.7, 3.7. Okay, 17.7. So that's the biggest.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thanks for following on Empty80. Welcome. Hello, Mike. How you doing? Right, I am not. I think we're going to reduce the number of levels down. I mean, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, that's 32. Ooh. So, I was hoping it wasn't going to be that many. Because we need the control X and Y, and we worked it out to AF for each one of them. So that's BO, that's 176 characters, 176 bytes. Oh. Poo. Right. I'm never going to fit this into a cassette 50 game. Or not if I'm going to be doing that by 3. That's a lot of the memory taken up. Times 3. That's half a K. That's not going to happen. So I'm going to abandon the cassette 50. So we'll just put it straight in. So we need a snake control array, and we will fill this what was it, BO, that was it, $BO, that many number of characters, 0 please. Next one, snake row array, same thing again. that's our array. Ooh. Okay. Right, number of active snakes. Number of active snakes. Here we go. Right, so I've got that. So when we're inserting a snake, remember we're not inserting a snake. We are inserting one character of that snake, and that snake could be a number of characters. So at the moment, as soon as we come in here and it says number of snake characters, that's how many characters we've got insert in. So if we go say level 1 is 6 characters, right? So we would be inserting a character every cycle, right? So that's why you get a character every cycle. So this is what we're doing by insert snake. It's not insert snake per se. I suppose we better name it properly. Insert snake character. Insert snake character. So here we've got our number of active snakes thing. So what we're going to do is we're going to increase the level number of active snakes, because now we're saying, right, this is it. This is how many snake characters we're going to put on this. We've just increased it by 1, so we're inserting now. Then load into X, because we're going to use X for our array, and we need to default. Now question is, we haven't got any controls in there, so okay, snake control tail equals tail, that's 80. I think it was 80. Let's have a look. I think the head was 40. Yes, so the head is 40 and the tail's 80. Okay, so that's 80. Got constant head equals $40. What was the body? What was the body? I think that was 0. I think that was 0. Hang on, I'm just checking. Yeah, I think that was 0. And then we've got a snake control left. Now I think that was 1. I think that's 2. Right, so there are control characters. So the control character is to tell the control point is to tell how that snake character is going to hey Dockster, is going to operate. Yeah, so we are going to load in the body. So the default we're doing is body, and then we're going to store that into the snake control array, comma x. Yep. And yes, we do. This is the cassette 50 stream. We're not doing cassette 50 today because GridRunner's not going to fit in it. It's definitely not going to fit in it. It might if I take out. I'm thinking of taking out the two ships that go that way and. Cool, that's difficult to do. That way and that way, yeah? So take the lasers out, so it just has the snakes going backwards and forwards, yeah? And I'm thinking of because we're taking the laser pods out and the pods out, we could start off with more snakes and longer snakes right off the bat. But I need to get the snake code into this to see if we can just have the snakes going through the system and how much it will take, because the snake array is going to take 500 bytes up, which is a lot in the cassette 50. Like breakdance. Right, so we need a start position. So the row is going to be 2. I think that's where it is. But and if I'm going to make this work for other computers, I need that. So it's not 2, it's starting at the matrix top, and the start column is going to be start column. Where we're going to do that? Let's make it relational to the screen size. So yeah, let's make it relational to the matrix size. So I'm going to say the matrix maximum size. No, that's not gonna. It's not gonna do it. Screen. That'll do it. So the screen width divided by 4. So at least that'll be in the first quarter of the grid. Right. So we need to. So the first one is the row. So let's make. Go away. I'm not interested. So snake insertion row, start row. Store it in snake row array, comma x, and LDA hash snake column, snake array, column array, comma X. Right, so that's now added that character into our snake array. So need to decrement the that. So now we're saying that's it. We've added that character, so we need to decrement off how many we need to put in. I suppose we'll need to check it. Now the reason why we're checking for 1 we need to define the tail, but we needed to define the head as well. I wanted to make it a bit more elegant than the way Mr. Minter's done it. Right, so define the snake tail and then return out of it. Oh, how does he define the head? Oh, he defines it there. Oh, there. Oh, yeah. Okay, so that's what we... Okay. Okay. Right, define the snake tail. So we're checking that we've got 1 character left on the snake to put on the screen. And because we've only got 1 character left, this is where we need to then insert the tail. So basically we're going to be inserting we're going to be is that inserting? Yeah, that's override. That's overriding. Okay. Right, so we decrease the number of snake characters. No. Because we're now going to be putting the tail in. Decrease the level number of snakes. Because this is the tail, so that's it, we've now done that. Snake control. What do you mean no suggestions? Really? Right, and then store this into the snake control array. So that's now set in that, and then we jump back out. So this is where we're adding the new snake. Right, define snake head. Oh yeah, yeah, because it would be 0 anyway when we start up. Right, so we need to reset the timer. We need to reset the insert timer. Right, so that insert timer, have we got an insert timer? No, we have the master timer. So snake insert timer reset. See if that will do it. And then store it into snake. What do we call it? Timer snake insert. Right, so that's reset our insert timer countdown, and now we can initialize. So we load level snake length and store it into level number of characters. So because we're inserting the head, we can now initialize how many characters we're going to be putting on behind it. Then it's right, increase level number of active snakes and LDX. So it's basically the same as that, same as this. So how can we make this a bit better? Because it's putting it in the same place. Okay. Let's put it here. No, it equals snake control. That'll do. Right, so we'll grab this. Do that. Get rid of, oops, oh come on, so we insert the point, and then we can do the same with down here. I mean, to be honest, we could do the increase as well. Increase the active snakes. Yeah, we could do that as well. So we could take all of this lot out, oops, out and put it there. So X is not actually in anything. Yeah, that'll do it. And then here, we don't need that or the corresponding LDX. Just need the character, which is the head. And we want it to go right as well. So when it starts off, it goes right. And here, right is 1. So right is 1, left is 2. So plus so that should be 41. Insert it, which increases starts it off and then returns back out. So yeah, that is exactly what we want to do. There we are, save some code, some more bytes saved. Right, what are we doing next? So that's the insert done. So we've inserted the snake character by character into the screen. So this can be now that. Right. So we've inserted the snake. It'll just drop out if we're not inserting a snake. So we need to check to see if we've got any active snakes. Right, if we've got any active snakes, now we need it to do stuff. Yeah. So we need to make it come out. Oh, come on, it's there. It's right in front of me. Thank you. So, if the number of active snakes is 0, we just come straight back out. We come straight out. We don't want to do anything. So let's move that down. So, so we just need to now run through our array. Hello, Grey Defender. We need to run through our array. How am I going to do this? Because I don't want to do it his way. Right, he's animating the snake head. yeah. He's animating the snake head, but he's doing a No, we're not doing that. Good morning, Mr. WauloK. Have you had your coffee yet? Right, so we're going to work out how to animate between these two characters. Now that's dead easy, because what we're going to do is we're going to basically flip between the two characters. So between character 81 and character 102, and we're going to flip between the two. So because we're using pesky characters, we can't put the two characters together if we was customizing the graphics. So we're going to flip between the two, and the way to do that easily is to XOR from the first one to the second one, and then XOR back to the first one, and XOR back to the second one, and XOR back to the first one. And so to work out what the XOR value between these two are, we just get the calculator up and running. And you go 102 XOR 81. So our XOR value is 55, right? So if we're at character 81 and we need to get to 102, so your XOR 55 comes 102. If you want to get back to 81, then you XOR 55 and you get back to 81, and that's how we're going to do it. So we need to put in here snake head any character x XOR equals 55, and that will allow us now to animate the head of the snake without having to do inc test. If it's this, then go to this. Right, so what we're doing, so we have loaded a number of active snakes, so we need to transfer that to the array because that's going to define where we are. Right, now we need to have I got a snake header animator character? So have a look. Yep, level snake header character. There we go. So what we're going to do is we're going to load that in. We're going to XOR with that, and then store it back. Right, that's our header, that's our snake header character being animated. So I need to, in the setup, I think I need to set up game setup. I need to set up the header character. I don't think I've done it. Setup level, activate game, that's what I'm after. Here we go, activate game. Have I, here we go. Yeah, so I've set it to that one. And I have changed the name of that timer, didn't I? That sorted that out. And that's not the add. Oh, I've already got it. I've already got it. Oh, there it is. Timer. Oh no! It's the master reset anyway. I don't think I've got that anywhere else. Nope, that can go. There we go. Right, so that sets the header character, snake header character 1, and then this now alternates between character 1 and character 2. So we don't need to do any testing and resetting and stuff like that. Hey up, Stacey. So we are now right, current snake index. Now I don't think I've got anything like that. Don't think I've got anything like that. No. So this is keeping track where we are. Level underscore current. Oh, come on. Oh, that's why. It's no colon. Right. Now this is the old jiggery pokery rubbish that he does, so we're going to try and do it differently. So he's loading the column. Okay. So we are who's stalking? So remember, we are moving backwards through. We are moving backwards through the array. So we're always. So we're always going to get the tail first of where the snake is. So because we're working backwards. So I need to figure out how to. I think the best thing to do. X is the column, Y is the row. So that's what we'll do. So if I want to use the stack, then I need to get the character first. Or do I? Okay. So he's okay. Yeah, let's do that. Load snake array. Oh, come on. And it with the tail control. So we're basically trying to find where the tail is. Branch if equal found the tail of the snake. Right. If we haven't, if it's equal to 0, that means it's not 80. But if it's 80, that means it's the end of the snake. Right, okay. So we will load A with the column snake, comma X. Push that to the stack. Load A, snake, row, which is Y. Transfer that to Y. Pull back from the stacks, transfer it into X. And load the grid character. Come on. It's there. Right, so what we're doing, because we've identified the tail, wherever the tail is now is going to be grid. So we're going to put the grid character where the tail is now, because everything's going to get moved, all right? So load the grid character. I've loaded X and Y. Ooh. I've loaded X and Y. Yeah, so we should then do put character at position. Then we're going to load grid color, JSR, put color at same location. So that's now blanked it out. Cool. Oh no, it's not found end of, that's it. Not found end of tail. Not found the tail of snake. That's what we're looking for. That's what it's called. Good evening, Mr. Kebab. So now we've identified the tail of the snake, and we've just blanked out that tail character on the screen. So we're going to carry on through now, and we're going to affect the actual character, the current element that we're on. So we need to load it back in the current snake index from into X. Load the snake control array, because we need to find out. So we need to find out what it is. Now we know it's the tail, but now we don't need to. We need to check for the head, because with the head we need to do something else with it. So control head. So if this is branch if not equal to 0, yep. This is the snake head. So we've identified the head, and we've got to go somewhere else. Now, what we're gonna do now is we need to ripple through the snake up to the head and move everything. So there's, oh, it's difficult to try and explain. Let me see if I can try and explain. Oh, piece of paper. See if I could try and explain. Right. Let's see if the camera's working. I ain't tested it. Hey, hello. Right. So here's our snake. 1, 2, 3, 4, 5, 6. So it's 6 characters. This one's the head. This one's the tail. Right? And so they're put on the screen like so. Yep. Can you see that, by the way? And so what we're going to do, because we're working this way in the array, we're working backwards, yeah? So we've just identified the tail here. The tail is in this location. And what we've done is we've basically blanked it out. So we've done that, yeah? Now, what we're going to do is we're going to move that to there, that to there, that to there, that to there, and that to there. So then this becomes the tail. And the rule is the tail this tail moves into the same position as its predecessor. So it checks where the predecessor is and says, right, I'm taking that spot, and then jumps, and we just store it in that spot. And then this one goes, right, I want your spot, and then jumps into that spot. And so on and so forth. And so that's how it is. So basically, when you look at the array, so we're talking X here, right? We're talking X. It's going across the screen. So the column array basically has, so let's say if that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, yeah? So this would be in column 11. This is in column 12, 13, 14, 15, 16, yeah? And then what we're doing, basically, yes, I did. I've ordered it. I've ordered mine. Yes, I ordered mine. So what we're effectively doing, we're not moving the character into the next screen location. All we're doing is we're moving that number into there. That number goes into there. That number goes into there. That number goes into there. And that number goes into there. Right? So it means now, effectively, when everything's done, it looks like this. 11, 11, 12, 13, 14, 15. Yeah? So we have two 11s. So when we identify the header is going to, it actually says what it's going to do. So the header character is 40. Yeah? If it's going, let's just have a look, just make sure. If it's going right, so if the snake is going right, then it's 41. If it's going left, then it's 42. And this number here determines what happens to the value in there. So if it's 41, that will be 11 minus 1, which then becomes 10. But let's say if it was going in the other direction, right, it'd be 11 plus 1, which then becomes 12. So we change it into a 12. So this array is pointing to the column on the screen. It's not actually placing the snake on the screen. It's just pointing to which column is that on the screen. And so it basically we're shuffling the numbers backwards as it moves along the screen. So this array never changes. We are just shuffling the numbers backwards or shuffling the numbers forward if the snake is going in that direction. And same with up and down. Up and down is exactly the same as well, but instead of using the column array, we use the row array for that. So that's what we're going to try and do. So hopefully that's explained how it works. Now in GridRunner 2, that it wasn't just 41 and 42. It was actually 41, 42, 43 and 44. No, 41, 42, 45 and 46. That was it. Because it went diagonally. So there was so it was, 41, 42, 43, 44, 45, 46. That was it. 41 and 2 determined which direction it was going, X and Y. And 45 and 46 determined if it was going up or down. So you could have 46 is up and to the left, 45 is up and to the right. Yeah? And that's how he made the control character work in GridRunner 2. Because in GridRunner 2 the snake can do the diagonals. It's not just like in GridRunner 1 where it just does the horizontal and verticals. So we need to do that now. We've identified where the tail of the snake is. We've blanked it out on the screen. Now we need to shuffle all the numbers up, down, however you want to look at it. So basically the way the quickest way is to take the snake control array, so a snake column array, comma X, but we want to take its neighbor. Yeah, remember its neighbor. So we are working our array that way. So we want to take the neighbor here and bring it this way. Yeah, so it's -1. So we're taking the neighbor of the point we're currently looking at, and then we're going to store it in where we're located. So that's done the column. So we do the same for the row. Oh, I don't know if it likes spaces, does it? Can never tell. Store it in snake row. Snake row away, comma X. So that's now just shuffled everything forward. And so what we can do now is we can, right, column is X, row is Y. So what I can do is I can push it to the stack, that's the X, transfer this into Y, pull back, transfer A into X. So that's setting up X and Y, our row and column. And then we can put our snake character. Now I'm trying to think, what character is this? This is not the header character. This is the body. So it's that, not that, not that. Snake character. There's that. So we load the character in, and JSR put character at location. Excuse me. Then snake color, load the snake color, color, JSR put color at same location. And I think that should do it. Just checking. So we shuffled down, we blanked off where this tail is, we shuffled everything down, we've just put that point there. So now we need to iterate through. Right. So, okay, cycle through. So we're going to have to jump to there at some point. So we're going to load our level current position, current index, and then de-exit because we've now finished with that position. We want to move to the next one, and we're not going to check, so we're going to branch to where are we going? Where are we going? Oh, it's there. Going here. And then if we've finished with the array, come out. Now, we need to done the body and we identified the head, so we need to put in all the code that deals with the head of the snake. Ooh. Now, like I say, the control character determines where it's going to go, so we need to check the control character. So LDA snake control array comma X, and we need to AND it with that branch if not equal to snake is going left. So that's where that's going. So that means we're going right. We're going. That means if if it's 2, then the only other one is 1. We're not doing diagonals, so we're going right. Dog. Dog. So so if we're going right, so we need to check where the we need to find out we need to check where we're going to go, because if we're going to go, we need, yeah. I'm just trying to think how we can do this without having to do loads and loads of coding, because Mr. Houdini WauloK, I've tried to ping him and I've had no response. I pinged him on Discord when he was on Discord and not heard anything. The GitHub with the coding hasn't changed since end of July. So I don't, to be honest, I don't know. I don't know what's going on. I don't want to step on his toes and start coding it myself, because ultimately it's his baby. But I don't know. I have reached out to find out what's going on. I don't know if lockdown's affecting him. I mean, the next version of CBM Prog Studio was meant to be the kick-ass upgrade. Yeah, it was meant to be the kick-ass upgrade. It was basically that CBM Prog Studio was going to work with kick-ass. So the editor would have been in kick-ass mode. It would have assembled using kick-ass. I wrote the error gathering routine. So when yes, yeah, I'm not sure if it's lockdown, but I wrote the error grabbing routine for kick-ass. So when you compile it and it errors, I've got a routine that takes those errors and then puts it in the error log like CBM normally has, and then you can double click on that error log and it takes you straight to the line. I've written all that, but I don't know what's. We have got a prototype that works with Kick. The editor hates Kick because that was the next thing, but we do have a Kick friendly prototype. I suppose I don't know if I could show you or not, because I've got the source. Like I say, I've got the source code, and in his GitHub, and like I say, I wrote the error trapping routine for the kick assembler. I mean, I was the one that wrote the GitHub integration, and he integrated it into his. I wrote the objects and the DLLs for the Git integration, and then he incorporated them into the software. He incorporated the kick assembler into the software, and I wrote the object that interrogates the file that Kit creates to grab all the errors so we could present them. But I mean, I pinged him other day, I think it was. Hang on, where's my Discord? Pinged him the other day. Pinged him yesterday. Yeah, yesterday. I pinged him saying, "Hey buddy, how's it going?" And he was online at the time, but not got a reply. So I know he had issues in first lockdown. In the first lockdown, he had issues, and I'm just wondering if this lockdown is struggling with this lockdown as well. And I hope he's okay. I hope his family's okay. I wish he'd talk to me, because then I would know. But I just don't want to. I just don't want to step on his toes in the coding. Yeah, I don't want to step on his toes by taking over the code. I mean, I will code whatever he asks me to do, and like I did with the error trapping routine. But I don't want to step on his toes. So I want him to guide me to, because we were both working on it, but I wanted him to guide me on what bits to code, yeah? Not just code it and get on with it. And so, yeah, I'm a little bit disappointed, because the plan was to get another version out for Christmas. That was a plan. The plan was to get the Kick version out for Christmas. And it was going to be CBM4. But lockdown affects people in different ways, and maybe I'm hoping he's okay. I really, really want to make sure he's okay. I kept pinging him. Anyway, so, and that's why I'm doing the graphics extension code in CBM. I want to show him that I'm still using CBM, and I'm using it on stream as well. I mean, I've got my name on it, for crying out loud. Of course I want to use it, but I think adding the Kick integration is going to take it to another level. Especially if the Kick, especially if it works with Mega 65, because we could use CBM Prog Studio using the Kick assembler to fire the Mega 65 up emulator, and that would take it to a completely different layer. You know, that CBM Prog Studio could now, as well as all the Commodore variants at the moment, it would be able to code for the Mega 65 as well. So yeah, please reach out to him. I mean, he's on my Discord. Private message him, even if he's not there. Let's see if we can find out how he is. Yeah. Because I've tried, and the last time I spoke to him properly was September. That's the last time he answered me. Mate, I'm looking at that. Because I've got the code. I'm trying to see if I can port it over to Mono Project. It's called Mono Project because CBM's written in .NET, yeah? And Mono Project is a Linux version of .NET, sort of, I think. Microsoft seems to have their sticky fingers in it, so I'm assuming that it is. And seeing if I can port it across onto that platform. The only other thing is to write it in C++. Oh, Microsoft bought it. What gets me, if Microsoft bought it, why, yeah, Mono, why didn't they go, right, there you go, Linux guys, there's .NET for Linux. The the design tools there, they could have replaced all the libraries with the proper .NET, but compiled for Linux. But Mono Project's there. I am looking at it. I'm trying to understand the differences between. I've got to get my .NET versions right now. Classic .NET, because they call it .NET Standard now. So I want to understand the difference between Mono and Classic .NET, so I can. Yeah. I thought that Microsoft had got the fingers in it somehow, but I'm trying to understand what the differences are and to see if it can be ported across. Because if it can be ported across, then I'm going to go for it. I'm going to give it a go. I'll probably do it in bits, so we'll work it out. But what I want to do is, if I can open source it and get people to help, that would be great. But I need permission, because if I'm going to base it on his code, and Arthur doesn't want to open source it, I've asked him, yeah. I think we could make a mono version of CBM Prod Studio for Linux. I've just got to WauloK in book 2, Derek's macros, because I've had Derek's book for a while now. I've been proofreading it and and playing with his chapters, coding on the chapters. He's done all the macros in Kick-Ass, right? They're all Kick-Ass macros. So the book is Kick-Ass orientated. So he's moved away. So it's Visual Studio Code. It's Visual Studio Code, Kick-Ass, CBM, C64 debugger, Sprite editor. I think it's called SpritePad, isn't it? And CharPad. So he's using those tools in this book. So he's trying to be as generic as possible. I mean, SpritePad and CharPad are Windows only, but there is a web version of SpritePad called SpriteMade on the web, which you can use in both Linux and Windows, and it exports in SpritePad format. It'd be handy if the macros preserved registers first. It depends, because you could preserve the registers first before you use the macros. Not every macro needs to preserve the registers. You only preserve the registers if you need to preserve them. For example, in here, I've preserved the macros on the timers log. Yeah, so I've preserved the registers and then restored them on the delays. Yeah, but I haven't done it on everything else, because you think to yourself, do I need to preserve them? And for the macros, you would do all that outside of the macro, run the macro, and then put it back. Well, I mean, how can I put this? Learn the macros. Understand what the macros are doing, yeah? Because if you understand what the macros are doing, then you can determine whether you need to preserve it or not. All right? Because you don't want to be putting PLA, transfer Y into A, PLA, transfer, blah, blah, all the time for all the macros, because then you're just creating masses and masses of code. If you understand what the macro's changing, then preserve what you need. Yeah? But I've had his book for a good 5 or 6 weeks now. And from what I was, when I read it, it was brilliant. I mean, I've been messing around with the code, and he's got a lot. He's put a lot of new macros in there. There's some rastering macros in there. He's got some sprite, multiplexing macros in there. But it's the simple multiplexing, you know, the regioned version of multiplexing. I know you're talking about preserving registers, but, you know, most routines you don't need to preserve registers. Anyway, I've lost where I'm going. Oh, that's it. Right, we was looking at whether we can make this whether we can make this a simple routine going left and going right. Okay. So he's moved everything over. Oh, he's doing that stupid screen column malarkey again. Right, so going left is macros are good if you want to do a lot of repeating code. They're also bad is that the fact that if you're using a macro to do something again and again and again, you could use a JSR. Yeah. But you've got to remember Derek's book is aimed at the intermediate. Yeah. The intermediate. Beginner to intermediate. So the function there is to help the beginner to intermediate programmer be able to code a game by understanding what the macros are doing. Yeah, and it's a fair point. It's a legitimate way of doing it. I mean, it was successful for book 1, so why shouldn't it be successful for book 2? To get people who've never coded a game before to have a game at the end of it, I think Derek's books now, because he's brought out the second one today, are a very good way for a person to get into it. And the first book did the shooter platformer. Now he's doing the simulation game with the beach hut effectively, using the same framework that he used in book 1. But I think once people get past the intermediate, they'll soon start to see that macros are useful in certain areas but not useful in others, and start going down the functional route where they write routines to perform certain tasks. I know, mate. I know. I think it's just personal taste, isn't it? I mean, as you can see, I'm not writing macros because I think macros now, for the sort of level of coding that I do, and probably yourself, macros wouldn't do the job. But I intend to. I've got an idea for a game I've got an idea for a game series using the new book macros, like I did with Neptune Lander in the first book. So I'm thinking of using the macros in this book to get people started in game creation, and so I'm not too sure if I'm going to do it in streams or in a video series yet. I've got to decide how I'm going to do it, because I want to get into Hunchback. And maybe I could use Derek's book to do Hunchback. Use Derek's book to try and develop Hunchback like we did with Neptune Lander. I haven't decided yet, but I need to get Hunchback started. I want to get into Hunchback. I want to make it a proper platform. I want to make it a proper platformer game. And a lot of people have been asking me about what's happening with Hunchback. It's still on the cards. We just need to get going. Cassette 50's got in the way. The Spiral got in the way. And GridRunner's got in the way. Hunchback Elite. But, Hunchback is going to be a community project, and maybe I need to base it on the book so everybody's understanding of all the macros. And that's what I was thinking of. If the Hunchback community project is a community project, so we should base it off a framework. Derek's books come out just at the right time, I think, for getting all the noobs on board and stuff like that. So yeah, it's a great day for us C64 coders because he's brought his book out. And like I say, I've been looking at, but I have bought it. I bought it today, but it's not coming until Sunday. But I did buy the colour version, so. So yes, right, where was we? Oh yeah, going left, so Great defender, behave.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Fast phase twit. Thank you for following. Great name. Is the colour heavier than the black and white one? I don't know, mate. I think it's just the colour one. All the pictures are in colour. I will buy the black and white one as well, because that'll be my workhorse one. Yeah, the colour one is just basically to seal it up. It's not going to get opened. Black and white one will be. Right, how are we going to do this? So I've got X and Y that determines where it is on the screen. I meant to oh. It's called humour. Okay. I don't know, mate. I ordered it this morning. And then I got an email saying it's not going to be here until Sunday. I ordered it this morning, so I thought it would be here at least 2 days, 3 days. Maybe the colour one is heavy and maybe it needs a dumper truck to carry it. I mean, it's 140 odd pages. The book is, I think. On the last draft that I got. Well, we've been taking the mickey out of him saying he's having printer problems. He can't print them out fast enough. I think Amazon's publishing it, but we've been taking the mickey out of him because, like I say, I ordered it this morning. I'm not going to get it until Sunday, so he must be having printer problems. And because I ordered a colour one, it's a colour problem. He's having to get some ink for his colour printer. But no, I think Amazon's publishing it. Right. So, we need to... Right, so it's the...
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thanks for following, Red Fox. Welcome. How you doing? Welcome to the Madhouse. Oh, we're doing all right. We're doing all right. Discussing the new book that was released today for us junkies. Yeah, there was a new book released today by Derek Morris, Volume 2 of C64 Coding. So I've just been discussing it. And how some people are getting it before me. It's not right. Right then, so this means it's going right. So we need to increase snake column array, X, and do it again. He's going. Get your hands on a Commodore 64. I've got loads. I've got loads of them. More than, well, I can count them, but I've got a lot of them. I mean, just in that cupboard over there, I've got 5? Yeah, 5 in there. Yeah, I used to do x86 assembly a long time ago. But then I found C. Well, before then it was F++ before then. And J++. Oh dear. That was a language and a half. Right. Back to what we're doing. Right. So we've increased, so going right, we've increased twice because we're decrementing once. Now, we need to find out what's in that place. What's in that place? Two C64s and Amiga. Oh, you mean the Mega 65? Yeah, because it's yeah. Oh, did you see the video that the Mega 65 team brought out not long ago? they've made this module. They've made this module that fits inside, that you can either plug in and it converts it into a spectrum. Did you see that video? Yeah, it's a core. They call it a core. Yeah, this is it.
Hello community. He took actually now the core data for this FPGA and ported this over to the Mega 65.
A lot of WauloK
And the guys also helped. I mean, they are really cool.
Ship this without a physical machine, so due to license. But I think with this cover, we should be able to show them something what people are working on.
Yes.
Also nice. In that case,
maybe. Oh, exactly. Yeah.
No, it's not that one. Or is it? Videos. Yeah, it's that one.
hello community. It's a huge increase in the community. What's it? No, that's
Oh, where is it? Oh, here it is.
Show the possibilities of game.
I also know scroll key press.
I keep this one here.
So he's got a spectrum there,
This
and
actually
this is the core
one
there.
of the newest spectrums. This is a ZX Uno, and here I will give to Anton, and he will explain why we brought this.
Yeah, I think this tiny little piece, how does all this goes together with the Mega 65? I think the easiest thing is just to start up and show you. Just close as usual. Our Mega 65 has several possibilities to store several cores. I also know scroll key pressed while switching on. I go directly into the flash menu of the Mega 65. And you can see we have a new core available. Under slot 2 we have a ZX Uno test 1, and I boot this one up.
So there you go. He's just booted into a
Side 2002
ZX
brought
Spectrum.
this, ported this core over to the Mega 65. And
So-
with next
I don't know how that is going to, how you'd be able to code that. I suppose you'd be able to code it as a Z80, wouldn't you? But it was it was interesting when I watched it. I thought, wow, it just booted into a ZX Spectrum. Hey up. I'm losing stuff. There we go. Well, this is what I thought. You know, that there's gonna be a lot of people now. You know, the Mega 65. We're just starting to get into it, and of course they're a lot of money. And then suddenly they've brought out this core that allows you to put it into ZX8 Spectrum mode. We're going to get everybody wanting one, and then we'll never get one. Right, I am thinking about doing this differently. Right. Temp storage, I'll use that. Oh, temp row and temp count. Oh, that's even better. There's temp row, temp column. That's even better. Right, so we will load snake column array, comma X. CLC. Ooh. It's all black magic. Alright, so the cores just make it think it's one of those. Oh, okay. Right. Can I do LDY, comma X? Tell me I can do LDY, comma X. That would save me so much time. Oh yeah. Oh yeah. Goody, goody, goody. Hey, like it when a plan comes together. Right, so store Y in temp column because we need to find out what we need to find out what's in the new snake location, the head location of the snake, because we need to check, is it the ship, is it a laser, is it a pod, because we have to avoid the other pods. So we're temporarily putting the snake head into the position where it should be. So if I then LDY snake row, comma X, and store that in temp row. Right, we should be able to get going then. So we need to first check what's on the screen. So LDX temp row, no, temp column, LDY temp row. Oh, Y is already set to temp row, so fine. JSR get character at location. Right, so that gets the character of where the snake is at the moment. So we compare it with grid character, branch if equal to snake can move there. So if it's equal to the grid character, then it's an empty space and we can move there. So we now need to check for the us. Check for us. Now I can't remember if I've already got. Have I got a routine that does that? Where's the lasers? Have I got a routine that already does that? Aha! Check for ship impact. Get in there, John. Get in there. Get in there. Right. Problem is, I'm doing the get again. Is that an issue? Is that an issue? Just means I'm reading the cell again. Copy paste. I'm trying to avoid copy paste. No, but what I can do is I can check the ship first, because it's going to come back anyway, because all we're doing is setting the death flag that if we are hit, yeah? So it gets the character, it's still, so gonna have to read it again because I destroy the accumulator here. So if it comes here, destroy it. So I'm gonna have to get it. I'm gonna have to load it again anyway. So we'll check for the ship. Then we'll check for the character. If it's not the character, as in it's not the grid character, why reinvent spaghetti code when you just... I'm not copy and pasting. I am not. If I've got a routine that does it, I'm using it. So we've checked. So we've checked for the ship. We've checked for a space. So now we are... So that means there's something in the way. So we go down. We'll always go down. So if there's, that means if there's something there, we are going to yes. We go down. I could try and explain it on there. But yeah, if there's something there, then we go there. Yeah. Right, so it's just a case of putting ourselves back to where we were. So LDA snake column array comma X, but I need to load snake index back so we know where we get it. So we load that, store it in temp column. So we've re-established that we're back in the place that where we were to start with, and now we need to move down. So inc temp row. So we're moving down, and for that we need to check that we haven't hit the bottom. Compare it with matrix. Bottom row, bottom row, bottom row. Matrix bottom row +1. So branch. if we are yeah, if it's not, that means we're okay. Do we check if there's a no, overthinking, John, overthinking. Not hit bottom of matrix. So this is saying we have hit the bottom of the matrix. And so we need to so if we've hit the bottom of the matrix, we need to trying to remember what it does now. Well, if we hit the bottom of the matrix, we can't go anywhere. What does he do? Hang on. What does he do? He does some and and oring. So, if we're at 41, so if the control character's at 41, then he ors it with 1, and then he ands it with FD. .41. So if it was 42, ors it with 1, and then ands it with FD. Oh, it sets it to 41 all the time. Sets it to 41 all the time. So it, okay, so it's, why set it to 41? Okay. 1, or it with 1 is 1, and it with FD is 1. That is strange. You have not won yet. I don't think it'll ever win. So what? Oh, he's just turning. Oh, he's turning it off, isn't he? He's turning the right-hand signal off. I mean, mate, I don't know. Hang on. I'm the host of this. I've got, 167,000 credits. So let me see. Can't spell. Do I win? winning. Oh, what is... Oh, there's a massive cooldown on it. Hang on, let me see if I can change the cooldown. Hello, you. Games. Gamble minigame. Oh, how do I stop the cooldown? Andy, do you know how to shorten the cooldown? How do we shorten the cooldown? Well, I'm a bit annoyed that there's a massive cooldown on it. But I can't see a cooldown on it. I'll have to see if I can find it. I'll see if I can find where the cooldown is. I even put I put a command in for steps when he joins. If you do -steps, oh, no, not hyphen, exclamation mark. Hang on, you have to do this. For when he loses. Well, I found the cooldown message. Right, I've turned the cooldown message off. Try it now. Right, so the cooldown's still on. It's just not showing the message. I'll figure it out. I'll look into it. I'll figure it out. I thought I turned off cooldown. Anyway, we detract. I've turned it back on. So it should tell you. Right, so what he's doing here is getting rid of the right hand bit on it. So he's loading. I've re-established X, didn't I? Yeah. LDA snake control array. So if it's going right, we need it to go left because we're going to place it at a specific position. So that's why he's doing the OR1. So he's doing OR1. So that's going to turn on left, but to get rid of the possibility of 43, he's doing this 1 2 3 4 1 2 3 4. He's doing that. So we're ORing it with 1 to make it go right. So it would initially go into right and then turning up left, and then turning off the right direction command. And so we store it back into the snake control. And then we're going to initialize where we want it to stay. So we want it to start at matrix top row. So it's 1 down. Store it in snake row array, comma X, and load matrix first column. Matrix first column. What's first column? 1. Yeah, that's right. We'll make it come in on 2. There we go. Snake column array, comma X. So now, basically what's happened is when the snake head, when we move it from there to there, right, we check to see what's there. If it's not our ship, then we're not bothered. But if it's anything else, we need to avoid it. So what it does, it puts it back there and then moves down 1. And then says, right, we're going in that direction. So it double backs on itself. But the problem is, if we're at the bottom of the matrix here, when you add 1, it's going, can't do it. So what it does, if we were going in that direction, right, and we're at the bottom of the matrix, we need to start it up there at the top end of the matrix, but we need to get it to go in that direction. That's what the OR in 1 and then ANDing with that is, to turn the direction into that, and then we're telling it to start from there. And that's how we avoid falling off the bottom of the matrix. And then we just need to place the character. So we have just done the column. We have just set the column, which is X. So we'll push that to the stack. We will load. No, we don't need to. We can transfer that to X. No. We need to push that to the stack. LDY snake row array, comma X. Pull from the stack, transfer to X. So that's the X and Y setup, and we need to then load the snake head character. Snake head character. Where's the... There we go, that one there, snake head character. and then we just do jump to put, no, JSR, to put character at location, then load hash snake color, and then jump to put color at the same location. And the reason I'm doing a jump is because we're going to RTS out, but I'll do it properly. Right, so that sorts out the fact that we've fallen off the screen. Oh, can't spell it. See if I win. Have I broken it? Oh, I must have broken it. Oh well. I must have broken it. It's dead. Well done, Aquafin. Right, so we need to then do this. Not hit the bottom of the matrix. So this is now saying that we've not hit the bottom of the matrix, and so we need to change the direction of the control variable. So snake control array comma x XO. And we need to change the direction of it. So we need to X with 1, 2, 3, 4, 5, 6, 1, 2. So that will change the direction. So if you don't believe me, right? So if we are hex 41, which means it's going, we're going 41 is right, I think, isn't it? Yeah, 41 is right. So if we're going right and we need to flip it to make it go left, you do XOR 3 and that should turn it into 42. Can use that when code fails. Cheers, mate. So if we've changed the direction, now we should be able to place we should be able to put the character on the screen. Oh dear. Right, so snake is okay to move. That's what we need to do. That one there. So snake is okay to move. And when we're up there, have we messed around with the X? Yes, we have. So we need to re-establish the X. And then we need to place Right, so so we need to load the X first. So LDA column array called X, push it, LDY snake row array, comma X, transfer, transfer A into X, and then load the current snakehead. Where are we? Put character location, load snake color, JSR, put color same location. Right. Re-establish the link. And so we need to loop back round to Snake Looper. I think. No. No, that's the start. It's the end, isn't it? This one. Right, so that's okay. That's okay. I think that's it. I think that's it. Let's add it in. Why are you not? Oh. Right. Let's see if we broke it. Well, they've not come on. The reason I put the noises in is because one baffles me, the SID chip does, but hopefully we will. But for the first one, which is going to be the pet, we're going to build this for the pet, yeah. So we've got to figure out how to make noises for the pet. But first, we'll do it silent, and then we'll figure out how to make the noises for the pet, and then we'll try and make the noises for the rest of the machines as well. But yes, hopefully it's going to make a lot of noises. Problem is, I don't know why it's not. Don't know why it's not doing it. Let me see. Process snake. Let's see if it jumps into there. Oh, okay. Let you off. So it is going in there. Oh, hang on. O2BF. Is 0. Okay, so it's gone in there. So it's loading 5. So it's resetting it. 2B9. 0. Ooh, that's not good. Or is it? Right, let's look at the numbers coming out of it. So it's 2CO. That's the one we're looking for. God, that's taken a long time to reset back down. Put a breakpoint after it. Branch if equal. So it's going there. Okay, 11. Get rid of that one. Is it actually getting there? That's a long time. Reload. Right, O2CO, let's see what the number is. So it's set to 0 to start with, and then goes to FF. Right, there's something wrong with there. And I bet that's to do with the level setup. Right, level setup. It's got to be here somewhere. Let's activate game. Here we go. Snake master timer reset. That goes into the master timer. That's fine. Game activation. What's it set to here? 10. Right. Right, okay. Snake insert timer reset, store it in timer snake insert. That's where it's going wrong. Right then, let's see if we can get this snake on the screen. Right, O2CO, that's the area we want to look at. Yep, that'll do. That's the area we want to do. Now we don't want that. We want OA something, wasn't it? Where is it? I can't remember where it was now. Let's step through it. That was it there. So I want to break there. Get rid of that one. Right, let's see if it gets in there. Oh, there we go. There we go. F10. Oh, and it blew up. Do I know anything about mono develop? I've been looking at the because there's mono project and mono develop. The develop is the developing IDE for mono, sorry. So I've been looking into that. Oh, Dockster. Okay. Right, I want to break it there. Get rid of that breakpoint. Right, so why did it fail? L02B4 OA, so it's resetting that. Resetting that. Right, so it's storing it in the control array. Now it's doing the test. Ooh. LDX is 1 away. Push it. Oh, that's where it is. There. Right there. Right there. O3E4. Where's that? How do I get the aha, O3E4. So this is place snake head on the screen. It's that. I don't pull it back, do I? Right. Well, we have a snake on there. Don't know what that one is. Right. It's 11 o'clock. I've been on how long now? 3 hours. I'm going to investigate why it's not moving, but it's definitely put on there and it's definitely going. I just need to understand why it's not moving, and that may take a while. So I'm gonna say bye for now, and see. Oh, what's that? OSK wants to know if it's close enough to Windows.net. Yeah. See if we can port CBM across. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.